Problem, online stock span problem. So this problem is easy, however it is of medium level. We need to just understand what it is saying and then it will become easy. So first of all, understand the problem statement first. So what we are we have been given is design an algorithm. We need to design an algorithm. So let us look at here first. So we have been given the stock spanner class where we have been given two functions which we need to complete it. What the stock spanner does is stock spanner initializes the object first, and what next is doing is next is the another function which is taking the price as the input and returning the span actually. Okay, so firstly understand, let's look into input and output. So as you can see in the input, we are inputting stock spanner, and we are initialize with the stock spanner we are just initializing the array. It is returning null obviously, and then we have the next. We are if we are inputting 100, so what it is giving us the output as 1, and then we have the again next function we are taking the input as 80. It is giving again as the output 1. So in that way we need to return the output. So first of all, what our work here is, we need to complete this next function. Okay, so let us understand what next is doing and how it is working actually internally. So next is returning the span of the stock price. So let us first understand the background of the problem. So for example, let us take this array. This is 7212. Okay, so here let us understand with this board. Okay, so what is this? 7212. We have been given 7, 2, 1 and 2. We have been given this. Okay, so what is this? So for this is the stock prices. On first day the stock price is 7, on second day the stock price is 2, on third it is 1, and on fourth day it is 2 again. Okay, so these are the stock prices. Now what we need to calculate, we need to calculate the span. Our next is returning the span. Whenever we are inputting for example 7 in the next function, it is returning the span of this particular stock price. Okay, it is returning the span of this 7. So what is the span actually? So what is span? So span is here considered as the number of elements which are actually lesser than or equal to that particular stock price on this day and before this day. Understood? So let me make it more clear. So for example, this is 7. Okay, now 7 is actually equal to 7, less than equal to 7. Okay, so our span will become 1. Now let us go previous to 7. Now is there any element here? No, no element, no element before 7. So our span will remain as 7. So our span will remain as 1. मतलब seventh 7 stock price span will remain as 1. Okay, now let us go to the next element 2. Now let us see, what we need to consider on this day and before this day. Okay, so on this day, okay, 2 is equal to less than equal to 2. Okay, correct, so its span is actually 1. Now we can see, okay, 7 is less than equal to 2. No, so our span will remain as 7, because what is span is the number of element which are less than or equal to that particular stock price on this day or before this day. Okay, now calculate. Now you calculate the span of 1. Are you able to calculate its span? Try it on you in your mind. What is the span for 1? Are you able to calculate it? If it's that, it's very good. If it's not, then it's also fine. I will make sure that you will be able to calculate the element or 2, this element span, last element span. So let me calculate this element span 1. So let us see, is 7 is less than equal to 1? No, so we are not counting it. 2 is less than equal to 1? No. 1 is less than equal to 1? Yes, so we will count span as 1. Now you will be able to calculate this. Calculate it. 1 2 3. Okay, now pause this video and calculate the span for 2. Okay, I hope you are able to calculate the span. Let's check the answer. What is the span for 2? What is 7 is greater than less than equal to 2? No. Is 2 is less than equal to 2? Yes, so our span will become 1. Now 1 is less than equal to 2? Yes, so our span will become 2. Now 2 is less than equal to 2. Yes, so our span will become 3. So the span for this particular stock price is on this day it is 3. I hope it is clear now. So that we need to return with the help of next function. So how we are going to calculate it? So first and the very brute force approach you can try by yourself is the using the array, vector array. You can do it by vector array, pushing into the vector array and then calculating the from this element up to the zeroth index is how many elements are less than or equal to that particular element. You can make it work, but the other very optimized and very easy approach will which take also less time. So we will discuss about that approach only. Okay, so let us go, let us understand that particular. Okay, so for doing that approach, okay, sorry, for doing that approach, we what we need one data structure. So what data structure we are going to use? Any idea? We are going to use stack pair. Yes, we are going to use stack pair. So firstly, let us dry run it. I will try to explain you that how it is going to work. So as you can see, we will take first 7. Okay, and 7 for that particular index, it is always remain 1. Like it's like 7 is always less than equal to 1. Okay, sorry, 7 is always less than equal to itself. It is 7 is equal to 7. So it is clear, like 1 like its span will always be 1. Like it is the least like 1 is always be the like span, minimum span for 7. It is clear. For all of these elements, one must be the least one must be the span for all. Like one is the least number that could be the span for all the element. Okay, so one should be there. Like if this for all the element, if there is a span, the span will be greater than or equal to 1. It is sure. So we will take as 1 for every element. We first start with 1 as a span. So what we will do, we will input here, we will push it here, 7 1. Okay, we will push it here. Now let's jump to the next element. Okay, now let's jump to the next element. Our next element is 2. So let us check. And its span also will be 1 because we are taking for every element, we are starting with the span 1. Okay, so now we will we will see the top of the stack. Now what is the top of the stack? 7. Is it less than or equal to 2? Is it? No, it is not less than or equal to 2. So what we will do, we will just push it here. We will just push the 2 1 to here. Okay, we will push it here, 2 comma 1. Okay, now next what we are gonna now next we reach out to the next element. So what is the next element? It is 1. Now our span will must be 1 for every element. Okay, so we are starting with this. Now we will see the top of the stack, 2. Now is 2 less than or equal to 1? No, so we again push it here. We just see if it is not less than equal to, if the top is not less than equal, what we will do, we just push the next element on the top. Okay, it is as easy as that. Just if it is, just see if it is not less than or equal to the stack dot top is not less than equal to the element we are taking the next element, then we will just push it up to the top. Now we'll take 2 comma 1, our last element. Now you see, like the top element, you see 1. Now 1 is less than equal to 2. Yes, it is less than. So if the top of the stack is less than equal to the particular element we have, what we'll do, we pop it. So we will pop it now again, and whenever we are popping it, what we are doing it, we are increasing the span. Now our span will become 2. Understood? Now again we see the stack dot top. Okay, its top is again less than equal to 2. So we again pop it, and what we do, we again increase the span for that particular element. Now it become 3. Now we'll see 7. Is 7 is less than equal to 2? No. So what we'll do, we push it over there. Oh, it's becoming so much of uh, so much nasty, like so much lines. Okay, so sorry for that. Okay, I hope like, but it is you are able to understand it. So now what we do, this much तो हमने निकाल दिया, like this much is not there. We actually popped it out. So now our next element is 2 comma 3, and 3 is what? 3 is the span of the 3 is the span of the 2. So that's how we are calculating the span. And you can also observe here, like it is the monotonically is a decreasing stack, because when we are going from bottom to up, what is happening? The element the first, like the element, the value of the element is decreasing whenever we are going from bottom to top. Now let us see what is the time complexity and space complexity for the particular problem. So as you can see, the space complexity for worst case scenario, for example, worst case scenario is when these are in decreasing order. For example, we are taking 7, we take 6, we take 5, we take 4. So what will happen? What we will do, if it is in decreasing order, then we don't need to do anything. We just push it onto the stack, and then stack will become, stack length will become n. Okay, stack length will become n. So how much space it is taking? In the worst case scenario, it is taking the on space. We are taking on space. Now let us look at the time complexity. So what is the time complexity for this? Are you able to are you able to calculate it? Okay, so let me show you, like, what is the time complexity. Even time complexity is O1, because we are just popping the element and then pushing the new element. Okay, even if it happening like for one time, if there are lesser elements, 1 2 3 4 lesser, like here we actually pop the two elements and then we pushed, even in that case only, even if it is happening, the amortized, like, time complexity will be actually 1. So time complexity will be 1 and space complexity is O(n). So now I hope it is clear, the whole question is clear, and we are using the monotonically decreasing stack. Okay, because this is the concept that actually monotonically decreasing stack or increasing stack, it actually has been used in many of the stack question. It is very important concept that we need to understand, because we know now, like, how we can be able to use this stack. Then we are that most of the stack questions, like standard stack question, will be covered. Now let's jump right into the code and code this problem, because that is the most important part. Okay, let's code it. We are taking the stack pair. Okay, try to visualize in your mind, like, how we are going to code it further. We are taking the stack pair, and okay, now we have, like, span. We are like, every price must have at least one as a span. So here our span is, like, let us name it as a span only for making it more clear. Okay, so our span must be at least one for every price, so we are starting with that one. Now what we are doing is this while loop. For every problem of this, for most of the monotonically increasing stack problem, we are using that while loop. Stack dot empty, sorry, stack dot empty. If it is not empty, then we will proceed further. Okay, and if stack dot top, sorry, pop nahi, it's top. If stack dot top dot first, because we are taking the pair here. Okay, that's why we are, if it is less than equal to the price, if it is less than equal to the price, then what we will do? Firstly, we will increase the span plus equal to, what we will do? Stack dot top dot second. We will actually increase the span, and another thing that we will do is we will pop the top element. And also, again, after doing all of this, we push our pair to the stack on the top of it. So span, sorry, price, it is the first element, and then we will push span. This pair we will, and what is we are going to return? We are going to return the span for that particular price. Okay, now run it and see, like, if it's working or not. Okay, it's working. Submit it for all test cases if it's working or not. Okay, it's working. So yeah, we actually solved this problem very well. Okay, so if you want to add something, let's comment below the down. Thank you so much for joining me.